Lesson 78, force vectors at a point. All right, we're talking again about vectors, so it has something to do with polar coordinates and rectangular coordinates. All right, force vectors are very similar to addition of vectors. All right, we're going to follow several steps to solve for these, combining different things that we've already known to be true. All right, force vectors is very similar to addition of vectors. All right, there are 4 steps that we're going to follow. All right, so let's go ahead and go over those first. All right, so step 1, draw out the forces using vectors and angles. Right, when we talk about forces, we're talking about 2 ropes pulling in an opposite direction, or a pulley with one rope extending to another. So we're talking about something being pulled or something being pushed. All right, so we're going to draw out the forces. A lot of times these are already going to be done for you, and so you just need to complete the diagram. So make sure that when we draw these out, we're labeling, we're filling in as much information as possible. All right, the second step is to find the rectangular coordinates. Right, we're finding the rectangular coordinates of each thing that's being pulled, or each thing that's being pushed, each force. All right, so we want to find the rectangular coordinates of each force. All right, the third step, once we've found each of the rectangular coordinates, we're going to add the rectangular coordinates together. All right, so we're going to find the rectangular coordinates of each one, add those coordinates together, and because our answers need to be expressed in polar form, we're going to convert back to polar form. All right, so that is step number 4, is to convert to polar form. All right, so those are the 4 steps to draw out the forces using vectors and angles, find the rectangular coordinates of each force, add the rectangular coordinates, and convert back to polar form. All right, let's take a look at some examples. On your example sheets, example 1. All right, example 1 says, 2 ropes are attached to a point and pulled on with directions and magnitudes shown. What is the resultant force on the point? All right, so we've got a rope being pulled in one direction. We've got a rope here being pulled in the other direction. All right, we want to know the resultant force. Okay, now, what we're going to do is we're going to complete this diagram by drawing it out, by labeling our parts. All right, so we're going to treat this like it's on a coordinate plane. All right, so if you need to, you can go ahead and draw your line there so that you can see it's on a coordinate plane. All right, now if we complete this vector, we have an R value and a U value. Again, same thing over here. We complete it, we have an R value and a U value. All right, so we filled in our information. What we're going to be looking for now is the U values and the R values. All right, so starting with the left side, if I use the sine of 45 degrees, I can find U using opposite over hypotenuse. All right, so to find U, I'm going to be doing 70 times the sine of 45. All right, if we plug it into our calculator, 70 times the sine of 45 gives me 49.5. All right, so my U value there is 49.5. All right, I'm going to use the cosine function to find R. All right, so we've got the cosine of 45 is the adjacent, which is R over 70. All right, in order to find what R is, all right, we plug it into our calculator, 70 times the cosine of 45, and again, that gives us 49.5. All right, so we've found our R and U values. We'll come back to those here in just a minute. All right, on this side of our diagram, we're going to be using the same functions. All right, we're going to use the sine of 30 to find the U value since that's opposite. Got the opposite over hypotenuse. in order to solve for u, we've got 40 times the sine of 30. All right, 40 times the sine of 30 is going to be 20, so my u value is 20. And then we're going to use the cosine function to solve for side r. All right, so we've got the cosine of 30 equals r over 40. And when I plug that into my calculator, all right, r is going to be 34.64. All right, so I've solved for r and for u. All right, that's step 2. We've found all of our rectangular coordinates. Now what we need to do is add them. This is probably where the tricky part comes in. Again, we're treating this just like it's on a coordinate plane. All right, so if we pretend that this is our coordinate plane, on this side of our problem, our u value is going to be positive, and our r value is going to be negative. On this side, our r value is going to be positive, and our u value is also going to be positive. All right, so we're going to start with the r's first. Here we have negative 49.5 r, and we're adding that to 34.64. All right, so if I combine those two r values, I'm left with negative 14.86 r. All right, and then we want to combine our u values. All right, over here we have 49.5 u, and we're combining that with 20 u. If I combine them, I'm going to get 69.5 u. All right, so we have combined, we found our vectors, we've added them to be rectangular coordinates. Now we just need to convert back to polar form. All right, so we're finally on step 4. We're going to convert these. Now, we're going to follow the same steps that we did when we're converting. All right, we want to draw out our graph, and we're going to label our parts. Now, our r value is negative, so it's going to be on this side of our coordinate plane. The u value is positive, so it's going to be up. All right, so our vector goes somewhere about here. All right, we're going to fill in our values. We've got 14.86. And over here for our u values, we have 69.5. All right, we're finding our vector, and we've also got to find our angle. All right, let's start with the angle first. To find the angle, we're using the tangent function. Okay, and remember, when we're finding angle, it's always the inverse tangent, right? Tangent is opposite over adjacent. So the inverse tangent is 69.5 over 14.86. All right, when we plug that into our calculator, we are going to find that x is equal to 77.93 degrees. Now, because x is inside the angle, and our angles that we look for start at the positive x-axis and go to the vector, we're actually going to be doing 180 minus 77.93. All right, so that means that our angle is actually going to be 102.07 degrees is what our final angle is going to be. All right, now to find our vector, we're going to use the Pythagorean theorem. All right, so we have 14.86 squared plus 69.5 squared, and we're going to take the square root of those. All right, so if you plug all of that into your calculator, you're going to get 71.07. All right, so our resultant force from those 2 points is 71.07 with an angle of 102.07. All right, so that completes it. We've used our 4 steps to solve this problem. All right, let's look at the second example on your example sheet. This one's a little bit different. All right, a point is acted on by a push force and a pull force is shown. All right, so the point is here. We're pushing on the force, all right, but we're also going to pull it. All right, so we're pushing in this direction and we're pulling up. Now, again, we're going to treat this like it's on a coordinate plane. So if I draw out a coordinate plane here, notice that I don't have a vector. Okay, I have something that comes out from that. That is actually going to be an r value. All right, so I actually already have an r value, and there is no u value on this vector, okay, because it's just a push force. So it's actually going to be a 10r value. Okay. All right, so all we need to do is complete on the right-hand side of our diagram, finding our r values and our u values. All right, so we're going to use our sine and cosine functions. All right, the sine of 30 is going to be the opposite, which is u, over the hypotenuse, which is 16. All right, if we plug that into our calculator, u is going to be 8. Then we're going to use the cosine function to find r. So we've got the cosine of 30 is equal to r over 16. Again, if we plug that information into our calculator, 16 times the cosine of 30, all right, that's going to give us 13.86. Right. We've finished our diagram. We've found both rectangular coordinates. Now what we need to do is add our rectangular coordinates together. All right, so we're going to add our r values and our u values. Now, notice that our first r value is a push in a positive direction. Since it is a push in a positive direction, it's going to be a positive r value. All right, so we have a positive 10 plus a positive 13.86 because it's also going in a positive direction. All right, so my total r value is going to be 23.86 r. And since I only have one u value, it's positive, it's moving up. All right, so it's going to be plus 8u. All right, so we've drawn out the forces, we found the rectangular coordinates, we added the coordinates. Now we need to convert to polar form. All right, so what I want you to do on your own, since this will be good review for you, I want you to go ahead and convert 23.86r plus 8u to polar form. We'll come back and we'll check that in class. Also, I want you to go ahead and do example 3. Try to give it a shot on your own. Use example 3 on your example sheet, and we will come back and we'll check this in class.